Let's get into the science of this then. So the chest-based wearable is actually measuring the electrical signals of the heart. This is what's called a one-lead ECG. Go away and Google it. The R symbolizes the left ventricle contracting, which is where most of the blood comes out of the heart and to the rest of the body. So we have another R wave over here, over there, and this is what we call the R interval. This is the gap between the two heartbeats. You see values of like 200 milliseconds. This is where we get our heart rate variability from. This is linked to things like readiness, fatigue, so on and so forth. The wrist-based wearable, which you might be able to see here, is this actually measures light. And there is a sensor that goes on the surface of the skin. It sends light down into the skin, and with this, it measures how much light is reflected back or absorbed or not reflected back. What it looks like is almost like a wave like that. So we have a blood passing under the light. There is a peak dampness of that light, and then it trails away again. This is when we recognize it as a beat has happened. So we have to have a good couple of these in a row to calculate what it might be over a minute. That's why this is more accurate for things like heart rate variability, but also heart rate. Whereas this, some wearables might think the heartbeat happened here, whereas other wearables might think the heartbeat actually happened here, just down to the light and how it functions. It's also more subject to error, thanks to light that could be coming in from the side, like your wristwatch is not very tight. That also has an influence on it too.